Assalamu alaikum jami'an. We're sorry for the delay, but we're just facing some technical difficulties. At the end of the day, this is very advanced technology, so just bear with us. Hopefully, our showers will start very soon. Thanks for your patience. Garzel, who is the CEO of the decentralized AI network SingularityNet, a blockchain-based AI platform company, CEO of Enterprise AGI company, True AGI, and the chief AI advisor of Hanson Robotics, where for several years he led the team developing the AI software for the Sophia robot. Dr. Garzel also serves as the chairman of the Artificial General Intelligence Society, the Open Cog Foundation, and the Futurist non-profit Humanity Plus. Dr. Garzel is one of the world's foremost experts in general artificial intelligence, a subfield of AI oriented towards creating thinking machines with general cognitive capabilities at the human level and beyond. He also has decades of expertise applying AI to practical problems in areas ranging from natural language processing and data mining to robotics, video gaming, national security, and bioinformatics. He has published 20 scientific books and 140 plus scientific research papers, and is the main architect and designer of the Open Cog system and associated design for human-level general intelligence. He obtained his PhD in mathematics from Temple University in 1989. So we're excited today to host Dr. Ben, and also hopefully have a demonstration of the Sophia robot, which I believe a lot of you are excited to interact with. So without further ado, join me in welcoming Dr. Ben.
Welcome, everyone. Thanks for coming to hear me talk a bit about AI and where it is and where I think it may be going. And at the end of the talk, we'll be joined briefly by my robotic companion. She's standing quietly over there. She's been struggling a bit with her internet connection, but hopefully she and her human helpers will get the problem solved while I'm here talking. So they've come from Riyadh, where the robot is going to be participating in the LEAP technology conference, and I'll be heading there after this as well. I was in Riyadh last year for LEAP this is my first time in Tamam or Dhahran, so I'm happy to be here. I had an interesting discussion with the university president and some of the faculty today, but it's good to also see the students. So obviously, what the university is actually all about. So, I've been interested in AI really since I was a little kid in the 1970s, and in the early 70s, I saw a TV show called Star Trek, which had an intelligent robot in one of the episodes, and in that episode, as always must happen with robots in science fiction movies and TV shows, in that episode, the robot went berserk and was trying to destroy people, since that's what people like robots to do in movies. And then the way they defeated the robot was by feeding it a logical paradox of some sort. So the robot believed, like, you like me, but you don't like me, but you do like me, but you don't like me. It couldn't handle the logical paradox, and it blew up, and the circuits caught fire. And I saw that when I was, I don't know what, 3 or 4 years old or something, and it annoyed me at that time, because I was like, wait, why can't this robot deal with a logical contradiction just as well as people can? Like, this doesn't make any sense. We're just trying to make up a reason why the robot is inferior to us. And that, I asked my parents, well, actually, why couldn't the circuits in the robot, think and adapt just like people could? They didn't have a good answer, and no one had a good answer at that time. But I discovered a few years later there was actually a scientific field of AI, and people were really working on the problem. But it was a small corner of computer science and electrical engineering back then. And even when I got my PhD in math in 1989, that was it was very hard to do creative sorts of AI research. I remember I tried to do a PhD thesis on using recurrent neural networks to predict time series. I couldn't find any supervisor for it. Neural nets were unpopular. It just seemed so weird and impossible to people. Whereas now that would be an undergraduate course project, really, right? And it's clear that it's a straightforward thing. So things have advanced quite rapidly, both in terms of people's acceptance and understanding of AI and the actual functionality of AI systems. But I think we're still not there yet to the level of AI systems like you see in science fiction movies. Like this AI in Star Trek was it looked like a metal box, like food processing machine or something, but it was it was traveling around the universe in its own spacecraft, exploring new planets and acting as its own sort of autonomous agent, charting its path through the cosmos, right? We don't yet have AIs that can act as their own autonomous agents and try to adapt to whatever new situation that they find themselves in, which is what I refer to as artificial general intelligence, AIs that can fundamentally generalize beyond their experience base in their programming and sort of take leaps of creativity to adapt to the unknown. And we're in some ways getting closer and closer to that goal, but in some ways, we're still quite far. There's a big breakthrough, I think, between here and AGI. I introduced the term AGI for the first time, I think, in 2004 with a book called Artificial General Intelligence. We had a bunch of papers outlining different approaches. And I've organized the conference series on AGI every year since, I guess, 2006. There's been a diversity of approaches to AGI in the research field, some of which I'll talk about today. But the other thing we've seen in the last few years is one particular approach to AI based on deep neural networks has gotten a huge amount of practical success in certain things and then a huge amount of popular notoriety. And I mean, the latest incarnation of this is ChatGPT, which is sort of taking the world by storm, and which I'm not sure will seem that significant in a historical sense, looking back. And then I think that the main innovation there was transformer neural nets, which were really created at Google Brain. It first came out in the BERT model from Google, and now that ChatGPT has gotten the public eye, there's going to be many more and better systems created by OpenAI and by others during the next couple of years. But still, ChatGPT is interesting at the moment in that it's sort of it's the first AI system I've seen that has sort of grabbed the world by the throat and made people say, wait a minute, maybe these machines really are going to become as intelligent as people are. I mean, it's quite far from a human level intelligence, as you see after chatting with it for a little while. In some senses, it fundamentally has no idea what it's talking about, and it can get some things wrong in ways that people never would. On the other hand, it is in some ways remarkable in how it can sort of synthesize information to give intelligent-looking responses. Operating slides is straining my own general intelligence. Give me a moment. There we go. So what? I think that the deep neural nets behind ChatGPT and other similar systems are very, they're very interesting and powerful in themselves. Not necessarily ChatGPT itself, but I think other successors to that technology really are going to eliminate a significant percentage of white-collar jobs that people do now, and similar technologies integrated with robots will eliminate a lot of blue-collar jobs in manufacturing and service industry and so forth. So I think even this technology, for all its narrowness and it's not being general intelligence, I mean, it still can have a revolutionary impact on the world. I mean, let's say over the next 5 or 7 years, 50 or 60% of humans are out of work because AI and robots can do all their jobs. I mean, even though we haven't reached AGI yet, that's quite a major disruption to economy and society. But I also think that these deep neural net tools that we see behind ChatGPT and similar programs, I think these can be a significant component of an AGI system, even if they're not themselves capable of AGI. And so one of the things I want to talk about today is how I think you can maybe get to AGI by putting together deep neural nets with logical reasoning systems. And this gives you what's called a neural symbolic approach to AGI. And then, of course, no one really knows how we're going to make a breakthrough toward human-level general intelligence. Some people think you can get there by sort of upgrading and tweaking current deep neural nets. Certainly the guys at OpenAI think that. Other people think you need something utterly different than anything anyone is working on now. Like you need a quantum computer, you need to grow a brain in a vat, or you need some totally different kind of algorithm nobody has ever thought of, right? And all these, you have to say, are still possible because we haven't solved the problem yet. So my bet is somewhere between these extremes, that the deep neural nets are a valuable component for statistical pattern recognition and synthesis. They don't do everything that you really need for a generally intelligent mind. You know, I'm going to explain a little bit about why I think that, what I think is coming in the AI field. And this talk is pretty high level and sort of hand wavy. I'm not going to go into deep technical details, but I will point out where you can look online if you want to find more technical details. So, looking very crudely at the long history of AI, I mean, you could really trace AI back to the 1930s and 40s with Norbert Wiener's book Cybernetics, the control and communication in man and machine. And I mean, the first papers on neural nets came out, I guess, late 1940s by McCulloch and Pitts, where they showed that artificial neural nets were Turing-complete computers. And they started building artificial neural nets with vacuum tubes, right? So I mean, this has been around a while, and you had a bunch of different AI methods being explored back then in the 50s and 60s, which is before my time. I mean, I was born in 66, but I mean, you had then people using, they beat the game of checkers in the late 60s, for example, which was a big deal at the time. They made the first computer algebra systems, which are now not even considered AI, they're just tools of what you see in programs like Mathematica and MATLAB and so forth. Neural nets were one of the tools being explored then. They became unpopular in the 1970s, I guess because people were making too much hype, saying they were going to do everything they're doing now, basically. But people were saying it in the late 60s and early 70s, and people stopped believing them. Neural nets became unpopular. Symbolic AI rose, and you have what was called expert systems. But this was a pretty silly approach, really, where people tried to encode in a logic language a rule for everything the AI had to do. You know, like if you go up to a microphone and want to speak, turn it on. If you want to speak, open your mouth, right? If you want to step, first lift one leg up, then put it down. And trying to specify as a rule everything the system needs to do. I mean, that in some sense it could work, but you would need like quadrillions of rules or something, right? I mean it's not practical. There was a project called Psych that coded many millions of rules, coded by like 50 people just typing in rules day after day, but it's not really a workable approach. You had also something called genetic algorithms or evolutionary learning, where you try to simulate evolution by natural selection, and that's quite interesting. It's a very creative method, and you could design artwork, you could design circuits. A number of patents were made by people using evolutionary algorithms, design new circuits and other things. But what really broke AI through, of course, was neural networks, which really coincided with the rise of the internet. I mean, the internet gave us so much data, and the internet brought us an upsurge in video gaming, which brought us GPUs, which then turned out to be really good for the matrix multiplications involved in AI, right? So then, with the internet, for all these reasons, neural nets trained on huge amounts of data started to rise to the fore and to do amazing things. And we saw, like, from 2014 to 17, computer vision transitioned from being a research corner to a major part of industry, and from 2018 till now, the same has happened with natural language processing. Now, what happens next? What happens next is not known. My own hypothesis is we're going to integrate neural, symbolic, and evolutionary AI to get to AGI. As I said, some people think neural nets will just be upscaled. Some people think all this is barking up the wrong tree. So, what do current neural nets not do well? I mean, we see what they do well with Stable Diffusion, ChatGPT, and other systems like that, and with neural nets for, say, classification, for identifying what's wrong with your lungs from a radiology image and so forth. So we see a bunch of things that neural nets can do well. What do they not do well? When used for synthesis of language or pictures, they make a lot of weird stuff up, right? And In images, it's just kind of funny. They make up a soccer player with 3 legs because they seem to know that people have 2 legs. For of course, medical question answering or something, it would be very bad because you don't want a fake medical diagnosis or them to tell you to drink bleach like Donald Trump or something, right? So, I mean, there's hallucination and confabulation, and an issue there is the system doesn't know when it's making stuff up. Like, it's cool to make stuff up, but it's fine. That shows artificial creativity. But not knowing when you're making stuff up or reporting something that was observed in the world is a problem for many applications. It's not for making graphic art. It's not a big problem. A person can just look at the picture and use it up. Self-inconsistency goes along with confabulation. I mean, you can ask the same question in slightly different ways, and you'll get weirdly different answers. Again, sometimes that's fun. Like I play keyboard in a band. The robot lead singer generates her lyrics by AI. If she generates weird random stuff, that's fine. And if it's different each time, that's cool, right? But again, for some cases, that's problematic. There's no ability to do complex reasoning, and there's no fundamental creativity, and that is worked around to some extent by having such a huge training database, right? So a real AGI system can do a wide variety of things, not because it was told exactly how to do all those things, but because it's making a leap beyond its experience. Like how I learned to use the internet, right? It didn't exist when I was born or when I went to school. You just put in front of you, and you got to muck around and figure it out. A system like ChatGPT can do a great variety of things, but it gets that generality just by having a very general training data. So like it read virtually the whole web. There's so much on there, and then it learned how to respond to all those things. So that's a cool trick for letting you do a great variety of things without being able to reason much and without being fundamentally creative. On the other hand, it does run dry, right? Like if you had a world population of 8 billion ChatGPTs, nothing new would ever get invented, because it's just recycling what was there before. Now, one thing it does is expose how repetitious and boring most human jobs are, right? Because you can obsolete most human jobs without coming up with anything, without much reasoning, just by repeating back stuff that was done before. But the fact that will do most human jobs doesn't mean that exhausts human intelligence. It just means that human jobs do a disservice to human intelligence, right? So these issues are well understood. What's not agreed is how do you overcome these issues, right? And that's to me, the biggest fundamental research problem in AI today. I mean, there are many other interesting research problems, like, how do you customize current existing AI systems to do this or that practical application? So for example, to control a robot to have a conversation, or I'm applying machine learning and machine reasoning to analyze DNA data from long-lived organisms to understand longevity. There's loads of cool application projects like that. But at the core of AI technology, overcoming these issues is probably what we need to do to get from here to general intelligence, because we have a lot of stuff already working now, even though these things don't work, right? And so it's a quite an interesting position to be in. So just as one example, one of my friends asked ChatGPT rather, which is made by the company OpenAI, asked it about SingularityNet, which is my own blockchain-based AI platform. What ChatGPT said is that SingularityNet and OpenAI were both co-founded by Dr. Ben Goertzel. And this was amusing for me to know this, because I actually had nothing to do with OpenAI. What was funny is that ChatGPT that was created at OpenAI thought in some sense that I founded the company that created it. But, I mean, of course it read OpenAI's website. It knows that's not true in some sense, right? But in another sense, it doesn't know anything. It's just piecing together stuff that seems related in the context of whatever whatever query it was asking. That's going to be hard to read on this screen, but this was a bunch of questions posed by Andrew Ng, one of the founders of deep learning. He asked the ChatGPT system, why is CPU computation faster than GPU computation for deep learning? Why is DNA computing faster than CPU computation for deep learning? Which is totally not true. I mean, DNA computing is incredibly slow. Why is abacus computing faster than DNA computing for deep learning? And each time it will come up with an answer. Abacus computing is generally faster than DNA computing for deep learning because it uses the principles of mechanical computation for this. I mean, if you don't know anything about it, it sounds very convincing and compelling, right? So it's funny. No one foresaw that one of the first really successful AI applications would be just coming up with compelling sounding nonsense, right? Just BSing people. And I mean, it's impressive. I mean, people get a lot of sales training to learn to BS people, right? I mean, it's an art, but it's not the art that we thought AIs would first learn. On the other hand, when you consider this an AI that's digested the whole internet, there's a lot of BS on the internet, right? So, I mean, it's also not surprising that that's what you've learned after reading the whole internet. So the underlying weaknesses here, I think, are we're doing statistical pattern recognition and generation. We're just looking at what's out there and figuring out how to combine it. We're not abstracting or forming concepts explicitly or implicitly. And the system doesn't know what or who it is and what or who you are, right? And I mean, it's interesting you can get so far without any of these things. It's also doubtful to me you can really get to human level or human-like general intelligence without these things. So there's a number of ways to conceptualize what is intelligence, and it may be that having a full sort of definition of what is intelligence doesn't even matter. Like biologists don't have a clear definition of what is life, and the fact that a virus is sort of life and sort of not life doesn't really matter. It's no objection to doing synthetic biology and making organisms either. So I mean, precisely defining intelligence, I don't think it's actually necessary for building intelligence. It's still interesting though. I mean, Marcus Huller, who's a mathematician and AGI researcher, now at Google DeepMind, he wrote a book called Universal Intelligence, which gives a math definition of general intelligence, which basically comes down to the ability to maximize computable reward functions in computable environments. Like, on average, over all computable reward functions in environments, how well do you do at achieving that reward function in that environment? And by that criterion, humans are very, very stupid. Right? Like I can't run a maze in 750 dimensions. I can't even figure out how to click the slides back and forth. So clearly, I cannot optimize all computable reward functions in all computable environments. I mean, as having taught university for some number of years, I realized like half of students couldn't figure out how to do differential integral calculus even. So on the other hand, there's still a sense in which we're more generally intelligent than like a rat or a monkey or a dog or a rock, right? So a different conception of AGI is given in the PhD thesis of my friend David Weaver. He has a notion of open-ended intelligence. He's trying to view intelligences as complex, self-organizing systems which are driven by two goals. One is survive, like individuate, maintain your boundaries as a system, maintain continuous existence as a system. The other is to self-transcend, to keep exploring and doing new things which obsoleted your previous boundaries. And you can formalize these just as you can formalize things about your reward functions. So I would say, if you look at this conception of intelligence, which is a little more biology-oriented, commercial neural net systems today just are not trying to do these things. I mean, they don't have to survive. They're not trying to maintain their boundaries. They're not trying to grow and learn either. They're just kind of different, a different sort of thing than an open-ended biological intelligence.